We're going to look at how to find an exponential equation given a word problem or a table of values, or you might even be able to be given a graph. Okay. First of all, we have to know that an exponential equation looks like this: y equals a times b to the x. Okay, b to the power of x. A is the initial value. Okay, the starting number, if you will. Okay, so if you're taking a note, write down starting number if initial value doesn't make sense to you. B is the growth rate or decay rate, depending on whether you're increasing or decreasing. Okay, for growth rate, it would be 1, that's a 1, plus r, which means the rate is a decimal. So if it's 2%, you would add 0.02. The decay rate has to be less than 1, so you will take 1 and subtract the rate. So if you're decreasing by 2%, you would do 1 minus 0.02, which would end up being 0.98. And in the end, you have to make sure that if something is decreasing, your b value is less than 1, and if it's increasing, your b value has to be greater than 1. Here we go. A town's population starts at 50,000 and grows by 3% per year. So you need to know a and b. You do not need to know y and x because those are going to be part of our equation. A is the initial value, starts at 50,000, and b is the, in this case, growth rate. So it's going to be, we're given a rate as a percent, right? A percent means out of 100. So if you do on your calculator 3 divided by 100, you will get 0.03. Or alternately, you can move the decimal over twice and fill in a 0. So we need to do 1 plus 0.03, which will be 1.03. So now our equation is y equals, or maybe even, let's erase that. Let's use better variables. Population equals 50,000 times 1.03 to the power of n for number of years. And there we are. That's it. And I could ask you questions about that. You know, what's the population after 5 years? There we go. The second example is a car is purchased for $20,000 a year, or $20,000, and depreciates 10% per year. It's going down, D down. Okay. So we need again to find A and B. B should be less than 1 now. A is the starting price, and B is the decay rate. So it's 1 minus, and 10 divided by 100 is 0.1, which is 0.9. So the equation now is, let's say value equals 20,000 times 0.9 exponent n the number of years. And there we are. And again, I can ask you more questions about it. I'm going to scroll down. Now I give you just a table of values. Okay, so this is tricky, but you know what? We still use the same equation, y equals a times b to the x. This is the starting number. Now this is tricky. It's not just this one, the first one in your table of values, because this table can be continued if you know the equation. It's actually the one that goes with 0. Okay, so it's the 5 there. So we have y equals 5, and then b is our growth or decay rate. So what are we multiplying by every time? 2. So 2 is our b value. In this case, it's not a percent. Okay, technically it's 200%. It's doubling every time. Okay, and then to the power of x. This time, this is not an application. It's just given table values can come up with the equation, and you know, the graph of this would look like it would start at 5 and it would go up by doubling, something like that. I would continue down here, but right, because we have negative x's here. We're not so focused on this, but it's just kind of interesting to be able to find it from the table values. I could You could also find it from a graph. So if I were to give you a graph like this, you could say, okay, 5 has to be that number in front. That's actually the y-intercept. Okay, so we're talking about just a pure relation. We're talking about that's the y-intercept. And then you're going to have to take a look at the different points here and see what's happening with the y values. Are they doubling? Are they multiplied by some other number? Are they decreasing? So are you going this way? Okay, and that's a little mini lesson on finding exponential equations. Hope you enjoyed.